All right, a few more comments on routers, and then we'll. I think that by that time we probably have beaten the dead horse here, but this is important, and probably one of the more important things that we'll review while we're going through some of the networking terminology here. We went through and started to learn some of these ports and protocols, and obviously they come back to haunt us if we don't know what they are. That's why I'm telling you 100%, if you don't know something, then ask the question, but also make a note card of what that is so you can go in and know that simple network management protocol, SNMP, which is what port? 161, or Telnet, which is what? 23. Usually, if you offer those up, they may end up giving you a little bit of a security gap because they can be set up in an unencrypted style. So what do you do as an alternative to that on the network? Well, some of the older devices would enable different versions of SNMP, like version 1 or version 2. And with the version 3, which is typically, when Microsoft releases a new server, I think now they're on server 2016, usually there's some new bells and whistles, the interface looks a little bit better, or whatever. Well, they also spend a lot of money making sure that their stuff is secure. Even though we always knock on Patch Tuesdays, Microsoft is one of the most security-driven companies in the world because they have to, right? There's a reason why it's the biggest software company in the world, and Bill Gates is one of the richest men in the world right there. But with unencrypted protocols, Telnet SNMP and SNMP version 1 and 2 here, there's security gaps. So what do you do as a mitigation strategy? Remember we talked about risk mitigation. In this case, if you scan a network and you see that they have Telnet or they're running SNMP version 1 or 2, you can go back to the customer and you can say, hey, instead of running Telnet, we're going to recommend you run SSH, right? Secure shell, or have secure copy, or the secure version of SNMP. So that's the encrypted version of that, and that's what you would do, right? So usually that's what we'll do. They create these internal tables that are called Kam Tables. And off the top of my head, I can't remember what that stands for, but in the Kam table, it actually shows all the routing of what has been built in that router. So if we want to route traffic from one node to another node, that would be in that router for a quick lookup, so it didn't have to every time go and look up, okay, where do I need to send this? The first time that it sends that traffic to another router, it will find the shortest path between that route and the next one, and then it'll hold that in its memory until you tell it to flush it out. And typically, you don't tell it to flush it out unless you put something that's a shorter path in there, and it'll automatically go through and learn that that's a shorter path. And we're going to talk about that here in a fantastic practical exercise that we have coming right up here. So some of the interesting things that you see here with routers are the different protocols. The routing information protocol, the border gateway protocol, and then the most commonly used here is the open shortest path first. So let's talk about the top two, and then we'll get into the last one here. So for the top one here, the routing information protocol, that basically tells the routers that are on the network the way that we're going to communicate. And usually it's over IP. Usually it's going to have some lookups that are in each of the routers for efficiency, make sure there's no latency or jitter on the networks. And for the borders also will have built-in tables, so we know where the border traffic needs to be sent to. And because of that, things like IPsec can then be stood up on a border router. So on that node to another border router, we can set up IPsec and then have that secure tunnel going through the cloud. So the open the shortest path first really, I think, is the most common sense way that we can explain routing. And for that, I think having done a little bit in algorithms, I think it's good for us to do a little practical exercise here. So let's talk a little bit more about the open shortest path first whenever we go into this practical exercise.